So today we're going to be looking at powers and roots. Firstly, we're going to have a quick explanation of what powers and roots are and of the methods we use to solve these types of problems. Then we're going to look at some worked examples and then some practice problems. So firstly, the idea behind a power is simply if I want to multiply the same number together multiple times, say I want to do 5 times 5 times 5 times 5, this takes a long time to write out if, say, you wanted to do this 10 times. So the idea is you can shorten this using the notation 5, 4, where this 4 is called the power. So this would be, you would express this by saying 5 to the power of 4. And all it represents is 5 multiplied by itself 4 times. So a simpler example would simply be 2 times 2. It can be shortened to 2 squared, which is of course just 4. Now, root is the opposite of a power essentially. So if I were to write root 4 with a 2 here, this means the square root of 4. And this is just the opposite of this here. So you start with a 4 and you'd end up with 2. Because this is what you have to multiply by itself twice to get 4. Similarly, if I were to say what is the third root or the cubed root of 8, I could also say that this is 2, because if I were to do 2 times by itself 3 times, I could write that as 2 cubed, which is 8. So 2 cubed, or 2 to the power of 3, is equal to 8. Therefore the cube, or the third root of 8, is 2. So these effectively, powers and roots, are the opposite of one another. They undo each other. The second type of power I wanted to mention to you is negative powers. Now, for reasons you don't need to know about at this for your exams at GCSE level, all you have to think about is a minus effectively just means 1 over. So every time you see a minus in the power, just immediately write 1 over. And then you write the same thing, but with the minus no longer there. So 2 to the minus 2 is equal to 1 over 2 squared, which is of course equal to 1 over 4, or a quarter. Another thing I want to mention is another way of writing roots is through something called fractional powers. So if I take the example I used earlier, if I write 2 cubed, I can say this is equal to 2 times 2 times 2, which is equal to 8. And therefore I can say that the cube root of 8 is equal to 2. However, there is another way of writing this. I can say 8 to the power of a third, and this would be called a fractional power. And this is exactly the same as this, just written in a different way. It's effectively just a matter of notation. Mathematically, there is nothing different between here and here. I'm going to talk about how you manipulate powers, how you deal with problems involving powers. So if I asked you what 2 squared times 2 squared is, well, the answer would be 2 to the power of 4. Because when you multiply numbers raised to powers, you simply add the powers when it's a multiply. And if I were to ask you what 2 to the power of 3 divided by 2 to the power of 2, or 2 squared is, because this is a divide, you would minus the powers. So you would do 3 minus 2, which is 2 to the 1, which can also be written simply as 2, because it's effectively 2 times by itself one time, which is just 2. So if we move on to this first example now, very similarly to the example I've just shown, here I'm multiplying the numbers together, so I have to add the powers together. So this is simply 4 to the power of 10, because it's 4 plus 6. It's probably worth mentioning now that if you were to be asked something like this, 4 to the 4 plus 4 to the 6, you don't add the powers, you don't times the powers. There's nothing you can do with this, simply because this is it's the same goes for if it was 4 to the 4 minus 4 to the 6. If these here are plus and minus, there's nothing you can do in terms of simplifying the powers. The only time you can simplify the powers is when it's a times or a divide. So these are good and these are bad. And don't ever make the mistake of trying to add the powers or take the powers away if these are plus and minus. You can only do these methods when these are times and divide. So moving on to the next example now. 6 to the 9 divided by 6 to the 5 rather. So as I say, this is a divide, so you simply do 9 minus 5, which gives you 6 to the power 4, and that's the answer. Some students remember this simply by, if you just look at the centre of the divide sign, it looks somewhat like a minus sign, whereas if you were to write a times sign, there's obviously nothing in there that looks like a minus, so some students find it easy to remember like that. So now if we move on to the next example. So this is another type of simplification where you have brackets involved. Now this means 4 times by itself 4 times, and then that whole thing times by itself again 4 times. So if I were to take a simpler example to explain this, if I do 2 to the power of 2 to the power of 2, this is the same as writing 2 times 2 times 2 times 2, because it's 2 times by itself twice, and then the whole thing times by itself twice. So if I were to write this out, I would end up with 2 times 2 times 2 times 2, which is 2 to the power of 4. And now you'll notice that this 4 is simply 2 times 2. I've timesed the powers together. So this is what you do in this instance here. I do 4 to the power of 4 multiplied by 4, which is of course 16. So now if we look at the next example. Now these are just some special cases that I wanted to mention that might trick some students in an exam. I've already mentioned what happens when you have a power 1. It's simply like writing the number itself, so you can just effectively ignore the fact that that 1 is there. Anything to the power of 1 is just the thing you started with. Now 5 to the 0 is another special case, and for reasons you don't need to know about at this level, anything raised to the power of 0 is equal to 1. So if this could be any number at all, if you raise it to the power of 0, it equals 1. And then again, 1 to any power is equal to 1. And now this one you can work out quite easily, because it's just 1 times 1 times 1 times 1 times 1, which is always going to be 1. No matter how many times you write this out, this is always going to be equal to 1, because 1 times 1 is 1. So the next example is a fractional power again. It's actually the same as one I mentioned earlier. So if I do 4 to the power of a half, this is equivalent to writing the second or the square root of 4, which is, now you have to think what you times by itself twice to give you 4. And this of course 2, because 2 times 2, i.e. times by itself twice, is equal to 4. So 4 to the half is equal to the square root of 4, which is equal to 2. Now this is a negative power. So remember, the first thing I said, when you see a negative power, is to write 1 over. So I'll say 7 to the minus 3 equals, it's minus, so it's 1 over. And then you just write the same thing without the minus underneath it. And now you just have to do 7 cubed, which is 7 times 7 times 7. 7 times by itself 3 times, which is of course just equal to 1 over 21. 3 times 7. Moving on to the next moving on to a practice problem, sorry. So this is now your opportunity to pause the video, have a go at this more exam type problem yourself, and then play the video for the solution. So, to deal with a longer problem such as this, you simply have to break it into separate parts. So first of all, I'll just deal with this part. So 5 to the power of 3 to the power of 4. Now remember the rule, which is if you have brackets, you simply times the powers across the bracket. So this is the same as 5 to the power of 3 times 4, which is 12. And now I look at the second part. So we now have 5 to the 12 to the power of 12 divided by 5 to the power of 2. So it's a divide, so you minus the powers, so this is equal to 5 to the power of 10. And as I say, this is more like something you might face in the exam, something a bit more complicated than what we've seen previously. So now moving on to the next practice question. Again, pause the video, have a go at it yourself, and play the video when you want the answer. So, again, we break it into sections. We just look at what's inside the brackets to start with. So 5 to the power of 5 divided by 5 to the power of 3. Because remember, a fraction sign such as this is simply another way of saying divided by. So this is equal to 5 to the 5 divided by 5 to the 3. Which is equal to 5 to the power of 5 minus 3, which is 2. So now we have 5 to the power of 2 to the power of 3. We just do the bracket trick again. 2 times 3, 5 to the power of 6. So I believe there's another practice question. So again, pause the video, have a go, play the video when you're done. So if I were to break this into sections again, just look at the first term, 27 to the minus a third. So we're being asked to deal with two things here. We've got a negative and a fractional power. So remember, the same rule stands. Whenever you see a minus, the first thing you write is 1 over. And then you write the same thing underneath, but without the minus. Now we look at this in more detail. This is effectively just asking us to find the third root of 27. So that is, what do you need to times by itself 3 times to get 27? And the answer to that is, of course, 3. 3 times 3 is 9, times 3 is 27. So now 1 over 3 times 3, looking at the second part now, is equal to 3 divided by 3, which is of course just 1. So 1 is your final answer. Right, now this is a much more involved question, so this would be a very high level question on the exam, it would be worth a fair few marks, and it's the kind of question that would separate the students that have revised from the students that haven't revised perhaps so well. So you're being asked to find the value of k. So the idea is to simplify this expression on the right hand side here, and you will end up with n, which can represent any positive number, to some power, and it is this some power that will be the k you're being asked to find. So effectively it's just a fancy way of writing simplify the thing on the left hand side, and remember that you can treat n just as you would treat it as if it were any number. So if these are all 5s or these are all 4s, it doesn't matter, it's just representing any positive number. So again, pause the video here and then I'll go on to explain the solution. Right, so if we start with what's inside these major brackets first, and then we'll look at what's inside these smaller brackets. So inside this first smaller bracket we have n to the power of 3 divided by n to the power of 5. So, being careful to get this the right way around, this is n to the 3 divided by n to the 5. So you have to be careful here, because the temptation is, because 5 is a bigger number, to simply say 5 minus 3. But in reality, we still have to do 3 minus 5. So this ends up as n to the power of minus 2. Now, if we look at this second smaller bracket, where we have n to the 3 divided by n, remember anything sitting on its own like this is effectively just n to the power of 1. It's just we very rarely bother writing the power 1 because it's implied. So this is n to the 3 divided by n to the 1, which is 3 minus 1, which is n squared. So now rewriting this problem, we end up with n to the minus 2 to the minus a half times by n squared, all to the power of a third. So now we simplify what's in here. So we want to look at the n to the minus 2 to the minus a half first of all. So again, you just times across the brackets, which will give you n to the minus 2 times minus a half, which is of course just 1, times by n squared. So this is the same as saying n to the 1 times n to the 2. It's a times, so you just add the powers and you end up with n to the 3. So now rewriting it again, you end up with n to the 3 to the power of 3 to the power of a third. Again, times across the brackets, 3 times a third is equal to 1. So this just ends up as n to the power of 1. So to summarise the entire expression, n to the 3 over n to the 5 to the power of minus a half times by n cubed divided by n to the power of a third is conveniently equal to n to the power 1. Back to the question, we can see that the value of k is equal to 1. Now, there are a lot of steps in that problem, which is why it would be worth quite a few marks in an exam situation. But if you can do this level of problem on your own, then you should get a very good mark in any type of these questions that come up in the exam. Thank you very much for watching the video, and feel free to drop in any questions that you may have into the comments section, and I'll get back to you as soon as I can. Thank you.